Question number 9 deals with electric flux. From a bulb, what comes out is light. From a magnet, magnetic field lines. From a charge, electric field lines. So when you say electric flux, if there is a charge plus 1 coulomb, number of lines coming out, number of lines coming out of 1 coulomb charge is 1 by epsilon naught. What is the value of epsilon naught? 1 by 4 pi epsilon naught is 9 into 10 power 9. 1 by epsilon naught is 4 into pi into 9 into 10 power 9. Comes out to be what? Equal to, yes, 1 point into 10 power 11. So number of lines coming out of 1 coulomb charge is 1 by epsilon naught. If it is 2 coulomb charge, 2 by epsilon naught. If it is 3 coulomb charge, 3. Number of lines coming out of q coulomb charge is q by epsilon naught. So if there is a q coulomb charge, number of lines coming is q by epsilon naught. What is electric flux? Total number of electric lines coming out of charge q is called electric flux. So what is electric flux? Total number of lines coming out of q coulomb charge. Time with you is 3 minutes to write. What is electric flux? These lines coming out of charge is electric flux. Out of 1 coulomb charge, it is 1 by epsilon naught. This value is 10 raised to the power 11. Objective question. Number of lines coming out of 1 coulomb charge, 10 to the power 7, 10 to the power 9, 10 to the power 11, 10 to the power 13. Answer is 10 to the power 11. Out of q coulomb charge, yes, q by epsilon naught. Out of 2 coulomb, 2 by epsilon naught. Out of q, q by epsilon naught. So what is electric flux? Lines coming out. How? E is number of lines per unit area. E is defined as number of lines per unit area. Electric field another definition. E is defined as number of lines per unit area. Suppose there is a torch and you get light out of this torch. If you place a ring here, maximum light will pass when the ring is in this position. Agreed? So light, this is light rays. If you place the ring like this, that is plane of the ring is perpendicular, then maximum light passes through this. If I start rotating this, light passing through the ring will keep on decreasing, and when it is in this position, light passing through the ring is 0. We want to write it in this form. This is 1. Area is a vector quantity perpendicular to the ring. E, I was referring to light. E is referred to as, E is number of lines per unit area. As an example, E is suppose 10 lines per unit area, and area is say, this is centimeter square, 2 centimeter square. E dot A comes out to be what? 10 lines per centimeter square, area is 2 centimeter square, comes out to what? 20. So here it is maximum, this is 1. And you agree, this is scenario number 1, case number 1. And for this case, when ring is parallel or area vector, if this is the ring, this is the ring, then area vector is perpendicular to plane of ring A. In this case, what is angle between E and A? Yes, 90 degree. In this case, how many lines are passing? 0. Now we want to come out with the formula, a general formula, where this is direction of E. You have a ring. This is area vector A. Angle between the two is theta. Do you agree that number of lines passing, number of field lines passing is equal to what? E represents what? Number of lines per unit area into area. We want to take into account the directional aspect, because when you rotate this ring, this is electric lines. When you rotate this ring, when direction changes, the effect, the outcome also changes. That is why we can write this as E dot A, which means what? E is equal to what? Sorry, electric flux phi E is equal to what? E dot A. Various cases. Diagram number 1. This is case 1. This is case 2. For case 1, yes, E and A are, yes, E and A are parallel. Angle between the two theta is equal to what? 0. Phi is equal to E. Dot A means what? E into A into cos theta. E A cos 0. It is what? E into A into 1. In this case, flux linking is maximum. Case number 2. This one. What is the angle between E and A? Theta is equal to 90 degree. Electric flux is E dot A, means E A cos theta. E A. Theta is equal to what? 90. Cos 90. Cos 90 is what? 0. The second case, the flux is 0. Simple. If you rotate this with change in theta, the outcome is different. If angle between area and E is theta, then flux is E dot A. This is what we want to explain. Electric flux is equal to electric field, which is a vector quantity, dot area, which is also a vector quantity. Time with you is 4 minutes. B part is again electric field due to point charge using lines concept. Electric field due to point charge. Using the same concept, that is electric field lines. What was the formula for force? Q1 Q2 by 4 pi epsilon naught r square. What was the formula for E? Refer to question number where you have defined E. 7 or 8? 7. What was the formula for E? You have already covered. E is equal to Q by 4 pi epsilon naught r square. Now we want to do this using field concept. Let there be a charge Q. How many lines will come out of this? Yes, Q by epsilon naught. As per definition, E is defined as what? Number of lines per unit area. So E is equal to number of lines per unit area. Out of 1 coulomb charge, how many lines? 1 by epsilon naught. Out of 2 coulomb charge, out of Q coulomb charge, total lines, Q by epsilon naught. If you want to find out electric field at this point P, just like if it is a bulb, light moves in all the 3 directions. If it is so, charge Q gives electric field lines in all directions. So if there is a point, charge Q, R distance, R distance, R distance, R. If you join all these points, it comes out to what? Symmetry is sphere. What is the surface area of a sphere? 4 pi r square. If this distance is R, area, this area is 4 pi r square. So it is 4 pi r square. What you get is Q by 4 pi epsilon naught r square. It was the same expression in question number 7. Means what? This electric field line concept is in agreement with your original law, F is equal to Q1 Q2 by 4 pi epsilon r square. If, as an example, if it is 1 coulomb charge and you have to find out field at r is equal to 1 meter, as an example, then electric field comes out to be what? How much is the charge? 1 over 4 pi epsilon naught. R is also 1 meter, 1 square. 1 by 4 pi epsilon naught is equal to what? 9 into 10 power 9. SI unit, you can write number of lines per unit area, or you can write force per unit charge, means what? Newton per coulomb. Question number 7, how E was defined? Force experienced per unit charge. Force, unit for force is Newton, for charge it is coulomb, so it is Newton per coulomb. One more which you may get is volt per meter. That is the third definition of E, voltage divided by distance, volt per meter. So in numericals, you may get Newton per coulomb or you may get volt per meter. Time with you is 3 minutes to write. Refer to numerical. All these numericals are based on, we refer to numerical number 20. All these numericals are based on electric flux phi is equal to E dot A. Numerical number 20 is a rectangular surface of sides 10 centimeter and 15 centimeter is placed inside a uniform electric field of 20 volt per meter. It is page number 1 by 115. It is 1C, chapter 1C. Such that normal to the surface makes an angle of 60 degree with the direction of electric field. Find flux of electric field through the rectangular surface. Write what is given, what is required. Given is, E is given. How much? 25 volt per meter, or you can say Newton per coulomb, SI units given. Direction given? We will write it, not an issue. Area. Yes. Area rectangular surface 10 centimeter by 15 centimeter. 10 centimeter by 15 centimeter, 150 centimeter square, 150 into 10 raised to the power minus 4 meter square. Angle between the two. So you need to draw a diagram. This is direction of E. This is any area, no doubt. In this case, it is a rectangular area. I am marking it as a ring. Not a problem. Perpendicular to this area, A. Angle between the two, 60 degree. Theta is also given as 60 degree. So to find out what? Find electric flux. Write the formula. Phi is equal to E dot A is equal to E A cos E is equal to what? 25. Area 150 into 10 raised to the power minus 4 SI units. Cos 60 theta cos 60 is 1 by 2. Comes out to be what? 1 point in 10 power minus 1. 1.8 into 10 raised to the power minus 1. SI units, you can write this as SI unit. This is what? Newton per coulomb, this is meter square. So SI unit you can write Newton per coulomb into meter square. Numerical number 22 is the electric field in a certain region of space is 5I plus 4J minus 4K into 10 to the power 5 Newton per coulomb. Calculate electric flux due to this field over an area of 2I minus 1j into 10 raised to the power minus 2 meter square. Given is what? Given is electric field E equal to what? Yes, 5I plus 4j minus 4k into 10 raised to the power 5 Newton per coulomb or volt per meter. Area 2I minus 1j, k is not there, that means 0k into 10 raised to the power minus 2 meter square SI units. You have to find out what? Flux. Concept. Step number 1 is concept. Phi is equal to what? E dot A plus 1 dot product of two vectors. Try. Right value for E, it is 5I plus 4j minus 4k dot 2I power also, that I will write at the end, 2I minus 1j plus 0k. What was power with the first part? 10 raised to the power 5. What was power with the second part? 10 raised to the power minus 2 into 10 raised to the power minus 2 SI units is equal to, yes, dot product of two vectors. Multiply components of I. 5 into 2, 10. 4 into minus 1, minus 4. 4 into 0, 0. That is on this 5 into 2, 4 into minus 1 and 4 into 0 is 0 into 10 raised to the power. Yes, 10 to the power 5, 10 to the power minus 2, 10 to the power 3. What do you get is 6 into 10 to the power 3. SI units. What are SI units for E? Newton per coulomb. Area meter square. Numerical number 25. A positive charge of 17.7 microcoulomb is placed at center of a hollow sphere of radius 0.5 meter. Calculate flux density through the surface of the sphere. Given is what? Yes, charge. Charge is how much? 17.7 microcoulomb. 17.7 into 10 raised to the power minus 6 coulomb. At the center of a hollow sphere of radius r. Radius 0.5 meters. What you need to find out is flux density. Find, when you say flux density, means what? Number of lines per unit area. Means what? You have to find out E. There is a charge Q coulomb. Number of lines come out of it. 1 coulomb 1 by epsilon naught, 2 coulomb 2 by epsilon naught, q coulomb q by epsilon naught. At any point P, which is at a distance r, what is the value of E? Yes, E is equal to, E is, how you define E? Number of lines per unit area. How many lines? Q by epsilon naught. Area 4 pi r square is equal to Q by 4 pi epsilon naught r square. 1 by 4 pi epsilon naught value is 9 into 10 power 9. Charge 17.7 into 10 raised to the power minus 6. Radius r is equal to what? 0.5. 0.5 square. Find E. 1 minute for calculation. Answer please. 6.4 E is equal to 6 point into 10 raised to the power Newton per coulomb. How many of you getting the answer please? Refer to numerical number 23. Question is, a charge 2 into 10 power minus 9 coulomb is placed in the corner of a cube of side 1 meter. Find electric flux passing through this cube. How much is charge given? Charge is 2 into 10 raised to the power minus 9 coulomb. Each side of the cube is 1 meter. So this is what is given. What you have to find out is, yes, flux. So you will have to draw a 3-dimensional diagram. Otherwise, you won't be able to understand at least 10 objective questions based on the same. There is a charge. Charge at corner. So from this charge, lines move in all directions. We have to find out how many lines pass through this cube. What is the flux through this cube? Find lines. Electric flux or lines? What is the term, right? Exact word used here is flux. Same number of lines, but in the question it is given. Find electric flux through help. Step 1, total lines out of q coulomb charge is q by epsilon. Total lines, I know. Anyone? How many lines will pass through this? Total lines, because they are moving in all directions. So they are passing through this also. What fraction of the total line will pass through this? Yes? 1 by 4. This is one answer. You're trying, that's good. Why you're saying 4? 1. If I extend it, I will draw how many cubes? 4. This is 1. Agreed? Still 50% of the lines are passing. 50% are passing above this. That means what? I need to draw 4 cubes more. Getting what I'm saying? Making sense? So step 2, number of lines in 1 cube, passing through 1 cube is equal to 1 by 8. It is not 1 by 4, but what you're thinking is the line is close enough. So it is 8. Simple. If you have a wall, common wall with a neighbor, you place a bulb on the wall. 50% of the light is available to your place and 50% is available to you, the neighbor. Agreed or not? Here, you're placing it at 1. And suppose there are total 8 houses. So one house will get what light? What fraction? 1 by 8 of. So Q is equal to what? No role for L. L has nothing to do with this. 1 by 8. Yes. This is Q is how much? 2 into 10 to the power minus 9. Epsilon naught is 8.854 into 10 to the power minus 12. Calculate an answer. Confirm that we are 28.25. Confirm we are 28.25 Newton per coulomb meter square as the answer. That is what electric flux.